Hello, 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 and welcome back to Algebra 1. We're doing Chapter 7-2 today, dividing monomials. Alright, gonna have a little bit of fun here. 3 divided by 3. Okay, there's no variable in the denominator. This is a monomial. 3 divided by 3 can be simplified, right? 3 divided by 3 is just 1. Okay, what about if I have 3 times 3? Ooh, getting a little more interesting here. 3 times 3 is also 3 squared divided by 3. I can cross these off. I can cross off the 3 here and a 3 there. Now remember, when I cross one off, that leaves a 1. Now up here, that's 1 times 3, which I don't necessarily need that 1 up here. I can just cross it off. But down there, I would need the 3. I'm left with 3 over 1, or just 3. So 3 squared divided by 3 is 3. Alright, let's keep this fun going. Okay, if I expand this a little further and say, what about 3 times 3 times 3? Okay, well, in this case, that's 3. This isn't 3 squared. This is 3 to the third power. 3 to the third power divided by 3. Well, I can cross this one off. Leaves a 1 down here. And a 1 up here. I don't necessarily need it because 1 times something is the number itself. 3 times 3. So that's 9 over 1, or just 9. Okay, you get the gist. I could keep going. This would be lots of fun if we just keep this going. But what if I expand it in the denominator? Alright, so now if I have 3 times 3 times 3 over 3 times 3. Well, that's 3 to the third power over 3 squared. 3 to the third power divided by 3 squared. I can cancel out this 3 and this 3, this one and this. Leaves me with a 1 in the denominator and just a 3. 3 over 1. Notice here there are 3 factors of 3. Here we have 2 factors of 3. So what am I left with? I'm left with 1 factor of 3 on top after I've canceled them out. Okay. Let's see. Let's go to, how about 5 factors of 3 over 2 factors of 3. That sounds good. There we go. So that's 3 to the 5th power. We have 3 to the 5th power over 3 squared. Well, what can I cancel out? Again, I can cancel out these 3's. I'm left with 3 factors of 3 on top, so I'm left with 3 to the third power over 1. So this is 3 to the third power over 1. And 3 to the third power is 27 over 1, which is 27. Okay, now, what happens if we keep reducing this? So instead of expanding, I divide by another 3. So we had this right here left us with, we had 3 to the third power divided by 3 squared. Okay, and that came out to be 3 to the first power. Right? 3 to the first power over 1. I don't necessarily need that over 1, but just for illustrative purposes. Now, what if I divide by another 3? Okay, well, that gives me 3 to the third down here. Okay, that cancels this out, cancels this out. That gives me 3 to the 0 power, because there are no more factors of 3. Okay, so 3 to the 0 power, and that is 1. Okay, we'll get to writing that down in just a little bit. All right, Let's look at that. That same thing works with variables too. So let's say I have a to the third divided by a. Then we get a to the third divided by a. We can cancel out one of those a's. Leaves me with a 1 here. So I get a squared divided by 1. Okay. If I get a to the third divided by a squared, then I cancel another one out. This goes down one further, a to the first, or just a. Right? There's only one factor of a left here. So write this down in your notes. Any number raised to the 0 power is defined as 1. 1 to the 0 power is 1. 2 to the 0 power is 1. 3 to the 0 power is 1. 4 to the 0 power is 1. You get the idea. All right, write that down. Anything to the 0 power is 1. Resist the temptation to say that is 0. It just means that 5 is used as a factor 0 times. Why is that? Remember, when we're canceling out, okay, this would be, let's start with this. This is 3 to the 5th power divided by 3 makes it 3 to the 4th power. And then if I move that, 3 to the 5th power divided by 3 squared is 3 to the 3rd power. 3 to the 2nd power. 3 to the 1st power. 3 to the 0 power. Okay, because this cancels out all of them. That's 3 to the 0 power. We keep going down. Now, if we keep going down further, that means we divide by more than we had initially. Okay, so here we have 3 squared divided by 3 squared. So that's 3 to the 0 power. 3 squared divided by 3 to the 3rd is 3 to the negative 1st. Okay, we went from 3 to the 0 power. That's this right here. And then we divide by another one. That's 3 to the negative 1st. Okay, and we'll come back to this concept a little bit later. All right, simplify this expression. We're going to write it out all the way, factor it out, and then factor this out, and we can see what can we cancel out. Well, those two g's cancel out, and then 2 sets of h cancel out. What are we left with? G squared, h to the 3rd. Over 1, so it's just g squared h to the 3rd. Simplify this. Now this is a division, but we have a power to power. This exponent applies to everything inside the parentheses. So we get 9 times p to the 6th over 49. Remember, 0 power, doesn't matter what's inside. Anything to the 0 power is what? That's right, it's 1. Okay, quick review here. 4 to the 4th, 4 to the 3rd, 4 squared is 16, 4 is 4. Remember, we're dividing by 4 every time. 64 divided by 4 is 16. Divided by 4 is 4. Divided by 4 is 1. Now, if we kept going, divided by 4, we go 1 further down. Negative 4th is 1/4. Same thing with 3's, right? Divide by 3, divide by 3, divide by 3. Divide that by 3 again. We're at 3 to the 0 power. That is 1. Same pattern here. Divide by 2, divide by 2, divide by 2. Divide by 2, we're at 0, and that's 1. All right. So negative exponents. If we keep going in this pattern, if we divide this by 4, okay, 4 to the 3rd divided by 4 is 4 squared. Divided by 4 is 4 to the 1st. Divided by 4 is 4 to the 0. Divided by 4 is 4 to the negative 1st, which is 1/4, or 1 over 1 factor of 4. Okay, 4 to the negative 2nd is 1 we divide that again by 4, we have 1 over 2 factors of 4. So 1/16. Okay, and so on. See what's happening here? Notice the pattern here. 4 to the negative third goes to 4 to the positive third in the denominator. Okay, so 4 to the third is 64 over 1. 4 to the negative third is 1 over 64. Notice how we can just flip it to the other side of the fraction. It's the inverse. So if you have a negative exponent, you're going to move that to the other side of the fraction and make that positive. Move this to the other side of the fraction and make the exponent positive. So I'm going to move the n to the negative fifth down, make it n to the positive fifth. P to the fourth stays on top, it's positive, and then r to the negative second gets moved up top, r to the second. There we go. Now I've simplified it, no more negative exponents. Okay, here, there's a lot of moving around to do and a little bit of canceling. Okay, so I can move the r to the third down, leave the numbers as they are, move the r to the third down, leave the t to the fourth, r squared stays in the denominator, t to the seventh stays down here, and then I'm going to move the u to the negative fifth up to the numerator. And then simplify, we can cancel out some of the t's here. And simplify 5 over 20 is 1 over 4. And after canceling out the t's, I'm left with 3 in the denominator. There we go. And that is it for today. Let that sink in. And remember to smash that like button like it's your business!